So, raise your hand if you love makefiles.
No.
All right.
I like that.
That fear, that like guttural, like visceral, make is my enemy fear comes from two things. The first is a really weird syntax, which is ugly, but is actually really good. It's just weird and ugly. And like a lot of weird, ugly things, if you can get past the weirdness and the ugliness, it's a pretty good thing. The second is that a lot of the people who use make are busy doing other things, and make usually shows up when you want to do a different thing, and so that's why it's annoying. Then you have to look at this ugly, weird syntax and feel resentful. But if you can get past the ugliness and the weirdness, it's actually pretty good. So the make manual is actually on GNU.org is actually really, really, really comprehensive. It has all kinds of stuff. I'm going to go through I'm barely going to scratch the surface, but you should really barely ever scratch the surface of make, because if you're using like super advanced features of make, you're probably off in a bad place anyway. So it's better to.
There's an O'Reilly book that's pretty good.
Yeah, there's also an O'Reilly book if you prefer dead tree style documentation. So basically, to do stuff with make, you type make in a directory that has a make file. The make file is kind of like if you're familiar with grunt or gulp, it's like the grunt file or the gulp file or the package.json. It's the thing that tells make what to do. You can also pass a -f flag on the command line to say, no, use this other make file. But it's just, everybody just always calls them make files. So with a capital M, that's important because of ancient reasons. Make is an ancient, venerable thing that's been handed down to us from generations of programmers. So a makefile is a collection of rules. Basically, every rule looks like this. There is a target. That's the thing that we're making. Usually this is a file, but it can also just be an arbitrary command like test. Then that target has a colon, and then a bunch of prerequisites, and then a bunch of commands to say how to make that target from those prerequisites. Another thing that's important, tabs. Tabs versus spaces. Makefiles eliminated the tabs versus spaces debate by only working with tabs ever. So most editors, when they see a file named makefile, will just automatically start using tabs, but it's like this is not optional. It has to be prefixed with a tab. So the target is required, and the prerequisites and the commands are optional. Usually you kind of have to have one or the other, otherwise it just won't do anything. But it's actually, make will be okay. It will happily do nothing. If you say make foo and there's no prerequisites and there's no command, it'll just be like, yep, I guess I'm done. So what we're going to do here, this is an example rule. As you can probably have guessed, everything that starts with a hash sign there is, or the hashtag symbol, is a comment. So the first thing that this is going to do is print out, this is, please read the makefile file to go through this tutorial. So by default, make is going to print out everything that it does line by line, so that you can see, oh, I'm compiling this file, and then I'm compiling this file. So when you get a whole bunch of output in a log or something, and it broke, and you want to go figure out why, you can say, okay, well, what commands was it running? That's pretty important. So what we're going to do is just bump the font way, way, way up here. That's taking a long time for some reason. And we're going to type make. And what this says, you notice it doesn't actually print out what those commands were. That's because I put an @ sign in front of each one. The @ sign means don't print this out. Just run the command, but don't print it. So if we remove those @ signs and then run it, you can say it's got a comment here that says to do actually make this go through some kind of wizard tutorial maybe. I didn't put as much time into this as there are actually some interactive tutorials that some people have built online, and I did no research before just cranking out something I thought might be handy. Then it says, okay, we're going to run this echo command, and then it runs the echo command, and here's the results. It printed out some stuff. Pretty straightforward, right?
Mm-hmm.
So by default, whatever is the first target in the makefile is the one that runs if you don't specify some other specific target. So it's pretty common practice to have like an all as your top level thing, and then that's the thing that makes all the things. So typing make here is the same as typing make tutorial. If we type make tutorial, you'll see it does the exact same thing. So yeah, we put the, why is it, there we go. So each line of the command list, this is kind of a one sticky thing that people bump into sometimes, trip over. Each line in the command list is run as a separate invocation of the shell. This is really important because a lot of compilers and stuff will just dump a whole boatload of crap into the environment, and if you don't start with a fresh shell each time, then they can like interact with each other in weird ways. But what this means is if we export foo equals bar and then we echo, what is the current value of foo, you're going to see that it doesn't show it. So if we make var lost, so even though we're exporting foo equals bar and then we're echoing foo equals and then $foo, what actually gets echoed is nothing. Just to compare what that looks like. For some reason, this is running really slow. If we did export foo equals bar, and then we did echo foo, you'd see we would expect that environment variable would show up there. Also, we have to use this weird double $ syntax. I'm going to get to that in a little bit. The reason is that before it sends the commands to the shell, it first interprets it as makefile commands. And in order to pass a literal $, you have to do $. So if we want to keep the variable that we exported, what we can do is actually escape the carriage return using a \. And then what it'll do is it'll run the entire thing as one command. So if we do make var kept, you can see it does export foo equals bar and then echo foo equals $foo, and we get foo equals bar like we'd expect.
Yay!
Yay! So that's all nice, but where make gets really interesting is when you have things that depend on other things. So, for example, you have an object file that depends on a .c and a .h file, and then a bunch of, like a binary that depends on a bunch of object files, or a CSS that depends on a bunch of style files, or something like that. So what we're going to do is actually build a result.txt from a source.txt using this wonderful CP compiler. The CP stands for C++ compiler. And the name of the thing is result.txt, right? That's the name of the result that we want. So if we do this, there's no rule to make target source.txt, which is needed by result.txt. Because we declared this as a prerequisite, if we don't have that, it will blow up. It'll stop and be like, whoa, 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 whoa. You want me to do a thing? You didn't tell me how to do it. There's two different ways that could happen. If we echo foo into source.txt, now we have that file, and so voila, we can make it. However, another way that we can do it is we can provide a rule so that it knows how to make source.txt. And what it'll do is go through its entire set of rules and say, well, you told me to make result.txt. What does that depend on? Source.txt. Okay. Do I have a source.txt? No, I don't. Do I know how to make a source.txt? So what we want to do is just uncomment this rule set here. Oops.
Okay. So CP.
CP just means for copy. I'm making a joke.
Yeah. But
so CP is the command I'm running to copy source into result.
and
why is it that you're telling it the same things twice? Like, you see what I mean? The source and the result are there twice. Why does it always expect to see source and results a second time?
So I will get to that. That is a really really good point. That we're specifying things an awful lot of times, right?
Okay.
I'm saying I want to build result.txt from source.txt, and then I'm saying cp source.txt into result.txt. Like I'm typing the same stuff over and over again. It's really tedious.
Okay.
That scary syntax is going to be how we solve that problem.
Oh, okay.
So now let's say that we can, now we've given it a way to know how to create source.txt by saying this is how you build source.txt. You echo stuff into it. Now if I do make result.txt, first it builds source.txt by running this command. Then it builds result.txt from source.txt by using copy. And if we cat result.txt, we'll see that it's the same file.
So the prerequisites, in the absence of a command with the prerequisite name, it means the existence of a file by this name?
Yes.
Okay.
It means I depend on this file. So what's really exciting now is if we make result.txt, it does this thing. If we make result.txt again, it says, yep, I already did that. I don't have to do that again. It is completely up to date. Result and source, source hasn't changed since the last time I updated result. If we were to echo some new stuff into source.txt, then it's going to notice, well, source.txt is newer than the result. If any of my dependencies are newer than the thing I'm trying to build, that means I need to build it again. This is the magic feature of make. This is something that almost every build tool doesn't get right. This is something that make nailed in, I think, what was that, 1907? Sometime around there. I think, I'm pretty sure Babbage invented this. Or Ada Lovelace, but Babbage got credit. Topical. So this, like you were saying, if you had a big project, if you have 100 C files, let's say, and I want to compile all of those C files and all of those headers into a single object, or into a bunch of objects, and then link all those objects into a single binary. Or if I had 100 little style files and I want to compile each of those into a CSS file and then link all the CSS files into a single main.css and then concatenate and then minify it or whatever. I don't want to create a rule for each one of those. That is super, super tedious and boring. So luckily Make makes this really easy for us. So what we're going to do is create one generic rule that says, this is how you make this sort of thing from this other sort of thing. And then we're going to do that by specifying a pattern and then matching things based on their stem. So if you have foo.c, you make foo.o. If you have bar.style, you make bar.css out of it. And then within the rule set, that means that when I'm writing that rule set, because I'm using a pattern, I don't necessarily know what the file name is, right? So we have these special commands that refer to just the thing that we're doing this rule on. The first one is $@. And this is the scary parts of make. So I should have put kitten pictures in this, but it's a text format, and maybe we could do like a
Yes.
There we go. So don't be afraid. It's okay. There will be kittens later, I promise. So the first thing is $@, and this is the target. There's two ways that you could think of this. The first is that it's like the $@ list in a shell script, if you're familiar with bash scripting, where $@ is the arguments list. And also A is the A in a circle is kind of like the letter A, which is for arguments. So when you type make foo, foo is the argument. Another way to think of this is that the @ kind of looks like a target. So this is the thing that I am making right now. the next one is the input file, which is the dollar and then the arrow pointing at it, which is like going into the money, because the input is how you go into the money. This is also kind of like file input piping in Bash, or command input piping. If you take, so it's actually just the first. You can have multiple different prerequisites. So the dollar arrow is just the first input file. If you want to get the list of all of the input files, you take it and you just turn it up a notch, and you get $caret, which is like, it's just like the $wacka, but it's like turned up. That's how I think of it.
They're great mnemonic devices.
Yeah, thank you. The $question mark is all of the input files that are newer than the target. So this one I've used it's mostly useful in debugging. So it's like, why are you building this thing? What? Wait, huh? If you want to know like what changed in order to make this thing necessary, then this can be really handy. Especially if you have cases where you've got like why does it rebuild this one file every goddamn time? And then you realize that you're depending on a directory or something silly like that. If you want to do because these are all $ things, if you need a literal $ in your commands, then you use $. And then $* is the stem part. So if you use the pattern matching, then star is like the part that matched the pattern. And there's like about a dozen or so other like fancy things that I've never used and I didn't even know about I've never even seen until I looked up the documentation on these specifically to know how to do them. So don't worry about it. You'll never see them. If you do, they're in the docs. They're not that hard to look up. So basically, then this thing that creates result from source could be done by by referring to the resultant source using these special variables. So what we're going to do is copy the input to the target. So let's try doing that. Make result from result using var. And we'll see it does exactly the same kind of command because those special variables get expanded to their appropriate names. Oh, that's interesting. $@ means something in Bash, so I should have put a slash in there. Maybe that'll do it. There we go. Okay, cool. So you have to escape it because Bash is going to then expand this to be an empty string because Bash is
tab completion some part of your magical shell, or so when you make.
I think it's some homebrew thing that I added, like make Bash completion, and I think if you just brew install Bash autocomplete, it'll like, or some kind of thing like that, then it'll autocomplete make files immediately, which is super, super handy.
Yeah.
So let's say we still would need to go through and define every single one of these things though, which is super, super painful. So let's say we had like 100 source files that we want to convert into 100 result files rather than just one off at a time. What we don't want to do is go through and create one of these rules for every single one of them, because even though we have these special variables, we still would need to create a separate rule for each one of them, and that's not scalable. So what we're going to do is actually just use a little bit of shell scripting to generate them and then save that into a variable in the makefile. Makefiles are actually, fun fact, makefiles are Turing complete. You can define functions and macros and all kinds of other crazy stuff. We're not going to do that here, but we will define variables because that's really, really common. If your makefile is Turing complete, you're probably a jerk, and don't do that. So note that this uses $equals for assignment instead of equal like most C-style and shell-style languages. I'm not sure why that is. Bad syntax. It's ugly. It's okay.
It's just another arbitrary thing to remember.
Yeah, the sooner you accept that this isn't Bash or shell, then the better off you'll be. Makefiles are their own language. They're a pretty simple language, but it's a pretty ugly-looking language. If you can handle shell and Perl and PHP and JavaScript, like you'll be fine. So typically you would use the wildcard function in Bash to get this list of things, because probably you're writing these files, right? You're like creating the style files, or you're creating the C files, or the JavaScript files, whatever, coffee files. And so they'd already exist in your project. But this is a tutorial, and I didn't write out 100 text files. So I'm going to just use this command right here, source files equals shell echo source slash 0 to 99.txt. And what that's going to basically do is just create a list of a bunch of text files.
Why do you need shell in there?
Because that's the function to tell makefiles that this is a shell command. Run this in the shell. Remember, makefile is not bash. So even though $paren is run in a subshell in bash, $paren in make is either evaluate a variable or execute a function.
Okay.
And in particular, there's a built-in function called shell, which is run the argument as a shell command. So we can actually show source files. The way that you then refer to the variable is $ and then in parens the name of the variable name. So what this is going to do is just echo out the name of all of those files that we defined in the variable. Make show source files. And you can see it's pretty much what you would expect. One thing that was a little bit of a surprise to me was that it's doing just 0.text instead of the 0 padding. That's because it's sh, not bash. If you hadn't just recently been working on a bunch of stuff that has to mimic bash, you probably wouldn't have even noticed or cared. So now what we're going to do is define a rule that uses a stem, that uses a pattern. So what we say is the way that you make anything that is source, and then we use the % sign, which is kind of like a star on the shell. The way you remember that is that a % sign is like a star in the shell. That's the mnemonic. And so anything that is source slash %.txt, like any text file in the source directory, the way that you make that is first we're going to just like make sure that the directory exists. One way to do that is to actually make the directory a dependency of the file. But because of the weird way that directories times get changed, it can be kind of confusing. I actually prefer to just do, create the source if it's not already a directory. And I put an @ sign in front of it because nobody cares about directory creation. You don't need to see that every time.
Is there a reason you didn't do make your p?
Yeah, it's the same, I guess.
Okay.
Not really. I mean, make your p would be just as good.
Okay.
And then what we do is we echo $* into the file name. So remember, $@ is the target that we're building. In other words, that resolves to source /25.txt or source /87.txt. The $* is just the bit that got matched by this stem, by this pattern. So if we now go and we run make source / oh, that should actually just be 0.
Zero.
Yeah. It would actually still work. It'll work for any source /. So if I do make source /.txt, it'll actually know how to do it because the rule matches, right? So source /literally anything.txt will echo whatever that literally anything was into the file. So if I do make, let's grab one of these though. Let's say I want to make this thing. Then it'll echo 54 into source /54.txt. Now, we still don't want to have to run make for each one of these files because there's 100 of them, and I don't want to type make 100 freaking times. That's ridiculous. So what we do, yeah, make is all about being lazy. Why should you make files? Let the computer make the files. So in order to...
So the make file?
Yeah. So in order to not have to run this for each time, we define a phony target, which depends on all of the source files, and it doesn't actually do anything else. It's good practice to define your phony rules in a .phony declaration, so that make will know that this is not an actual file. I shouldn't do a stat on it to see what its modified time is or anything like that. But at this point now, if I type make source, right here, we've got a file that depends on all of these source files. So it's going to get this list and expand it. So it'll be like doing source 1.txt, 2.txt, blah, 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 blah. And then what it'll say is, okay, do all those files exist? Let's see which ones exist. Oh, none of them do. So I'll go through and make all those files, and then I'm done, because I don't actually have to do anything else. I just have to make sure that the dependencies are there. So if I type make source, it flies through all of these, and then everything is good. And we can see we exited with 0. Why did that take that long?
It seems kind of slow. It's not streaming.
I don't know. It's running a bunch of bash commands. It's just like running 100 shell subprocesses that all do echo.
Yeah.
It doesn't do them all at once. It does them sequentially. And that's actually really important because the order of operations is really important when you're linking files together and when you're like building things.
So is there some overhead? I assume there's some additional overhead in doing things that way?
I could do make-j 8 source. Error 1, source 2.txt. I haven't tried this, so it could actually just be, there we go. It'll go faster if you pass a -j option. -j says is the number of jobs to do in parallel. So if you don't pass it, the default is just 1. It'll only do one thing at a time, then it'll move to the next thing. If you pass -j and then some number, it will build out the tree of stuff it needs to do, figure out which things don't have any shared dependencies, and so what it can do in parallel, and then do that many things in parallel at once. So yeah, make clean time make source. Let's see how long that takes. Took about 4.5 seconds. -j8. I don't know why that's failing.
That really
What? Oh, probably
Oh,
the make dir is failing.
that's why you just run it the second time and it goes okay.
Right. And it's a little bit faster.
So where would the phony be? That's something I don't understand.
If you had a make
The
file
phony
running-
is down at the bottom.
Okay.
You can only have one phony declaration, so it's common practice to put it at the bottom of the file. I don't know why.
You're saying that these are not files?
These are not files or directories. These are just arbitrary like phony commands.
Okay.
People type make test and it will run things, but it will not generate
Gotcha.
something at this time.
Right.
Gotcha.
So let's say now we have a bunch of
Like
source
that,
files,
basically.
and we want to create those. We want to create destination files out of all of them. What we do is, we should put a -p there so it doesn't fail. So what we want to do is anything that's dest and then has this this same kind of format, we want to have it depend on source and then the same stem.txt. So the reason why we use this percent sign here is that whatever the percent sign matches here, it will expand to in the dependencies list. So if I have source/foo.txt or dest/foo.txt, that's going to expand to source/foo.txt.
So you wouldn't use $$ there.
No, because I want to copy the full file name to the other full file name.
No, I meant as instead of the second percent sign using the $.
Oh, no. No, because the $* is only within the rule set.
Okay. So you can only have it in the rules, not in the destination or source.
Yeah,
Or
in
the
that-
parameters thing. Okay,
In that, you
target
just
or
use
something.
the percent sign.
Okay.
It's a weird syntax. I'm not going to apologize for it. It's bad.
But you love it anyway.
Yeah, so now I can type make dest/1.txt, and it will copy it. If I do a make clean, and then do that again, I'm going to first create the source, and then copy the source into the dest, right? Because it'll only make what it needs to. Now, note if I do this again, do you know what it's going to do?
It's going to say it's up to date.
Yep, it's going to do nothing because make is a lazy bastard. It's going to say, nope,
Laziness is a virtue.
I'm not going to do that. That's already up to date. And so this is great and all, but we don't want to type make/dest number sign, dest 1, 2, 3, 4, 5, blah, 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 dot text 100 times. So we create another phony target that depends on the destination files. This is another built-in function along with shell and wildcard that you see quite a bit. This is pattern substitution. It's a really, really simple pattern substitution. Basically, it just uses that same stem kind of system. So anything that's source/stem.txt, we're going to replace that with dest/stem.txt, and then the last argument is the list of stuff that you're going to do the pattern substitution on. Getting buzzed. Oh. And then we're going to say that, so that creates our variable list of dest files. And then a destination target, which is phony, is going to depend on dest files. So if we do make destination, or let's make clean first.
So you have a clean target in there. Okay.
Yeah, clean is not a built-in make thing. It's like test. It's a thing that you should put in as a sort of hygienic rule. People will expect it to work. Make destination is going to copy all of those source files into all those dest files. If I do it again, it says nothing to be done. So the difference with a phony target versus a real target is that a real target, if it's got nothing to do, it'll say foo.txt is already up to date. A phony target, it'll say, well, there's nothing to be done for destination because destination isn't up to date. That's not a thing.
So are we already in phony land here? Did you have a phony declaration?
Yeah, there's a phony declaration at the very bottom of the file. Source.
Oh, okay. So it's a list of targets.
Yeah,
Okay.
exactly. So destination isn't an actual file name, blah, 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 blah. So let's say that all of these dest files, right, so we have a bunch of source files that we're creating because we're typing away code in our project, and then a bunch of destination files, which are like, the compiled stylus to CSS, or the object files that are built out of our .c files, or the JavaScript that's built out of our ES6 JavaScript. And let's say we want to take all these destination files and then gather them up into like a proper compiled program. Since this is a tutorial, we're going to use the ancient feline compiler called cat, which is for, it's included in every POSIX system because cats are a wonderful core part of Unix. And the way, so we're going to build an object called kitty out of all of these dest files. And so if you remember, the $open angle bracket is the input file, but $caret is all of the input files because it's like you turned it up. So I want to get all of them. So we're going to cat them into the kitty by using the cat command, passing the list of all the arguments, and piping that into kitty. So let's make clean again, make kitty. First, it needs to create all the destination files. Let's say it crashes halfway through. Oh my god. Okay, it's going to delete the thing that it was in the middle of making because it probably is corrupted or screwed up or whatever. And if I type make kitty again, now I go and I fix the error in my program. And then I type make kitty again. What I wanted to do is start right back again at source/61.txt. And that is exactly what make does. It will just go and say, oh, all those other destination things, they're already there. They're fine. I don't need to make them again. It creates just the ones it needs, and then it runs the command it needs at the end to cat all of them into the kitty. If I run it again, it's going to say, kitty's already up to date. Now, where this gets really handy, and the reason why make is so great, this is where the magic happens. Let's say I edit one of the source files. We're going to edit 27.source, and okay, and then we're also going to edit 84.txt, and then we're going to edit 98 and 32, right? And it's not just me editing these things. It's somebody else in my team, and I'm just doing a get pull, and it just touches a bunch of stuff, and I go back to doing what I'm doing. Now I need to make the program again. I type make kitty, and we can see here it just copies the stuff that it needs to, just the stuff that's changed, because those are the only ones that the source changed, so they're the only destination files that could have possibly changed. And because some of the destination files changed, just more than one of them changed, it's going to rerun the cat to kitty compilation.
A change in the file's timestamp is what constitutes the change?
Yes, it's a, I forget if it's M time or A time.
It's in time.
M time. Yeah. Oh yeah, A time would be like anytime you
Yes,
read the
and
file.
You don't want that.
Yeah. What it's not doing, it's not hashing the contents like Git
Right.
would do, because that would be abusively slow when you're talking about large binary objects. And also keep in mind, Make was designed for systems where compiling one small C program into one small object file took a long time, like multiple seconds or minutes. And so the difference between if you had a large, like, you know, a text editor or an operating system kernel or a network stack, and you want to compile it, and we're talking about thousands of lines of code where even like a 10-line program compilation takes 5-6 seconds to do. This is the difference between an hour or two or multiple days of compilation time. And so that's why it uses just the stat results, because those are super fast. So what's happening here is I kind of explained all of that. We did the touch of the kitty and then remaking. So it's a good practice to have a test target, because if people see a make file, they're going to type make test. This should do a thing. It should not fail. And you know, even if all that test does is it runs npm test, or if all npm test is run make test, like that's fine. That's fine. You need both, because people will look and see a make file and type make test. So let's make test. Now all test pass. Lovely. If we do make clean again and then make test, we'll see it builds all the things. Make test should always depend on your final output of your project. Because somebody coming to your project from scratch should be able to type make test and have it run a test that runs. And last but not least, you've seen me do make clean a bunch of times. This is another good thing. If you have a make file, people will expect make clean to work. Make clean should delete everything that your make file created or could potentially create. Sometimes it's common to have like make clean, which only cleans up after you're a part of the project, and then make dist clean, which also cleans up after like upstream dependencies. We did this in Node because OpenSSL and V8 take a really long time to compile, and so you don't necessarily want to like get rid of them each time, because we're also not changing them that much. But make clean should definitely clean out like the node bin and all of those objects, because if you like really royally screw something up with the build, you want to be able to type make clean and get back to a nice state.
When installing software, the recommended sort of path is typically run make and then run make install.
Yeah.
So I see that all the time. Why is that 2 commands? Why not just have make do everything?
So,
Should do everything. Usually it does.
so the reason is usually that you want to run make as your user, and make without a target should never do anything outside of its project directory. So make without a target should just build stuff so you can test it locally. But if make starts dropping junk in user local, like I'm angry, because you don't do that. That's like presumptuous. Make install is like, okay, I'm explicitly telling you I want you to install this thing on my system, and I'm aware that it's going to have to do stuff outside of here.
And you may have to escalate privileges to do it.
Right. So it's pretty common to do make $& sudo make install. I personally am of the mildly controversial in some circles point of view that you should just, like, laptops are single user machines, and you should just own user local, as your own user, and I just type make install, and make install will do everything and install it as me, and it's fine. Seriously, it's okay. And multi-user systems, you shouldn't have them. We're past that. We have containers and VMs and okay. I'll stop ranting.
Soapbox.
Yeah, if you're on a multi-user system, you should get in your DeLorean and head back to the future.
They have mainframes. Have you seen their new mainframe? It looks great. It's cool. It's got like angular sides to it and stuff.
I heard Angular uses web components now.
I'll never leave my mud.
So one last thing that I do want to cover in this is what happens if there's an error. We actually saw this when I command C'd one of those things as it was running. But to demonstrate this, we'll use the false program, which exits with a code of 1 and does nothing else. False is super handy for tests and stuff. So the special variable make in all caps is, it says the make that is currently in use. So if I have like multiple copies of make installed on my machine, or if I've like set the path prefix in some specific place, or I'm using gmake or cmake or bmake or whatever, bsd make or whatever, the $ make will be like whatever make you're currently using. Use that to make kitty. Then call the false program, which that's going to fail. And then it's going to echo should not get here. So let's see what happens when we make bad kitty. It runs, as you can see here, this is a Mac, so obviously I want stuff under the xcode.app directory, because that's super discoverable. and then so this is the make that's currently being run, and then I'm making kitty. And that says kitty's up to date. Just what we'd expect, right? No need to rebuild the kitty. It's already fine. Then we run false, and what we see here is bad kitty error 1, because false exits with a status code of an error status code of 1. The reason why this is great is if you have a compilation that does multiple different commands, if any one of those commands fails, make just stops and it doesn't proceed. If you have something that you want it to be okay for it to fail, you have to do the double pipe true. True is kind of like false, except it always exits with status code 0.
Backwards to what I would expect. Like true is 1 and false is 0.
Or C land.
Right.
Yeah, shell exit status codes are kind of weird because 0 is actually just if you want to have like one possible success condition and then multiple different ways that it can fail, and I want to get information about why it failed. I don't ever want to get information about why it succeeded. It succeeded. It's fine. Then what you do is you want to have one value that's easy to test for to see if that's successful, and multiple values that can slide along a scale to be whether or not it failed. And the natural option there is to have 0 be success, because it's like a real, quick logical
Makes it
operation.
super easy to put programs together too. Like Nagios exit code of 0 is cool, an exit code of 1 is warning, and an exit code of 2 is error. So you can start to just like plug in any sort of checks you want, and then just the exit codes drive the program.
Yep. An exit code greater than 127 is the signal that the program got. So it's one byte, but like the low order bits are all exit codes, and the high order bits are all signal codes. And I think that's it. That's all I've got. So this is that Phony destination, the Phony source.
This is up on Dropbox
Yeah.
for the world, or
If you do make.phony, that's always fun, because it does a lot of weird crap.